simple pendulum represents a fundamental physical study of oscillation and mechanics. It consists of point mass spent from a 5-point by mass rock there, where moving from its equilibrium position is experienced a period of oscillating, moving influenced by gravitatory, constantly returning to its original position. The regular in its moving makes it an essential experiment in physical science along the detailed exploring of concepts such as the periodic oscillation. The time it takes to complete a cycle, the amplitude, the maximum distance from its equilibrium position at, on the length of the track after its dynamics during the simple pendulum, proving a solid theoretical and experimental basis from understanding. More complex thermal physics include various applications in fields such as quantum mechanics, dynamics of complex systems, and engineering, due to its ability to model and understand oscillator variation in broader context. In the simple pendulum experiment, a point mass is suspended from a tensor strike from the fixed point. The mass displayed from equilibrium position will oscillate freely under influence of gravity. Measured on the length of the rope, the mass uses the record and oscillate movement of mass overset. The time it takes to complete a full round 3 the period is tried and the range of motion, the maximum distance from the balance position are measured by varying the length on the rope. We investigate how they affect the period oscillation. It is discovered that the longer the length, the longer the period. This experiment demonstrates two relationships in the length of the strike in the period oscillation and valid the theory of the simple pendulum. Additionally, now must affect period analysis at other factors that can influence motion, studying, providing a deeper understanding of the fundamental principle and dynamic of the physical system.
Objective: determine the relationship that exists between the variation of length and gravity with the calculation of the period in a simple pendulum. A specific objective: establish a range of variable string lengths and measure the period of oscillation for each leg, keeping the mass constant in order to analyze how the period varies with length. Propose conclusions based on the results obtained, determining how the length of the string affects the period of the simple pendulum, establishing relationships.
A mass was tied to a pendulum and the length of the pendulum was measured to the center of mass. Then it was oscillated 10 times, taking the time it took. This time was taken 3 times to average the time and be more exact. This process is repeated to fill the first table. In the first measure, it gave average the time of 14 seconds for a mass of 50 grams. Taking into account the same methodology, the following data were taken.
Two mass was tied to the pendulum and the length of the pendulum was measured to the center of mass. Then I was oscillated 10 times, taking the time it took. This time was taken 3 times to average the time and be more exact. This process is repeated to fill the table. When you are reading have this data, the theoretical time, experimental time, and the percentage of error for each of the data rows are calculated.
The simple pendulum experiment has provided a deeper understanding of its dynamic variable by analyzing the relationship between the variation of the length of the rope and gravity with the calculation of the period. The direct influence of this factor on the oscillatory movement of the pendulum could be confirmed. It was observed that as the length of the string was varied, the period changed in the predictable manner. The longer the length, the longer the period, which aligns with established theory. This experience demonstrated the usefulness of the simple pendulum as experimental system to understand fundamental concepts of physics, while highlighting the importance of experimental rigor to obtain more precise and reliable results.
A system of pendulum suspended by the half of negligible I used to describe two types of motion, periodic motion and simple harmonic motion. By studying these systems, concepts such as period, oscillation, and conservation of energy can be understood. To carry out this laboratory, we took into account several formulas to be able to define to theoretical time, experimental time, error rate to the calculate theoretical time, the cap of the simple pendulum. The formula is T is igual a 2pi por raíz de L sobre G, where T is the period of the pendulum, L is the length of the jerk, and G is the acceleration due to gravity. To calculate the experimental time, the actual period of the pendulum is measured in the laboratory using a stopwatch. The percentage error can be calculated using the formula porcentaje de error, que sería theoretical value, experimental value, sobre theoretical value for 200, where the theoretical value refers to theoretical time calculated from the form, and the experimental value refers to the time measured in the laboratory. Remember that the percentage error indicates the discrepancy between the theoretical and experimental value expressed as percentage of the theoretical value. If the percentage error is small, it indicates good or great between the theoretical and experimental values. The first time we have to this is defining which mass we are going to choose and measure this mass. Taking all this data into account, we proceed to perform the experimental. And we calculate the percentage of error. For the same mass, we have to perform different oscillations and repeat the process with 4 different maze.